Prableen Kukreja, and I'm from IIT Tirupati, a PMRF scholar doing PhD there. And today we are going to start with the week 5 computer networks session. And one more thing I want to share with you, I have uploaded the notes and all whatever we have done in the class. I'll share the drive link in the chat. Wait a second. Okay, so you guys can see the chat box and see that I've shared the link. Are you able to open it properly? Okay, I think access is not given. Okay, need access permission. Yes, yes. Wait a second. One minute. Now, please, can you check? Are you able to open it? Can someone write in the chat? Yeah, okay. Thank you, Niranjan. Thank you, Sushmita. And whosoever want to see the video lectures, again, I'm sharing the YouTube channel name. This is the YouTube channel name. So you can see the videos. I think does it have MCQs? Yes, it do have the MCQs. There is a PDF separately which is uploaded of the MCQs as well, Diksha. I think I received the mail, but I was busy last week. Now only after the lectures, I think Nilanjan, you have mailed me. I'll reply to the mail, whosoever have, and I'll make sure that I'll reply as soon as you send me. This week I was busy, so sorry for the delay. I think you asked it out. I'll reply to the mail after the class only. Before, tonight only, for sure. Okay, let's start the lecture. So any doubts till last lecture? Then only I'll proceed. My voice is properly audible and I'll share the screen as well.
Yes, ma'am.
Okay. So this was the previous, last week we were discussing about stop and wait and the sliding window protocol, and we discussed some MCQs as well, and then we went to go back in and SR, selective repeat. Any doubts in those go back end and selective repeat? Can someone can give me the brief overview of what was stop and wait protocol and what is go back end and what is selective repeat, so that I can proceed with some numericals? Yes, come on. Or I should, or you want me to have a brief overview again of those? Actually, we are already, yes. Yes, what about others? Good evening, Vedic and Vivek. Yes means I should give the brief overview, or some one of you will explain, like summarize about go back and SR and stop and wait protocol.
Yeah, I can give a brief summary of this.
Okay.
Yeah, so go.
Yes, yes.
Yeah, yeah. In go back in, so the sender can transmit multiple frames before needing an acknowledgement.
Hmm.
So if one packet is lost, the sender must retransmit all the packets.
Hmm.
So that is go back in. So the number of frames that can be transmitted is up to the window size.
Hmm. Yes. What
And then
about?
in selective repeat, yeah, in selective repeats, only the lost packets are retransmitted. Instead of retransmitting everything after the lost one, only the lost packets are retransmitted.
Yes, absolutely. And what about stop and wait?
Stop and wait is basically to ensure that, yeah, mm,
Stop
yeah,
and wait.
it's
Yes, yes, yes. Come on. Yes.
Yeah, it's basically we need to ensure that we need to wait for an acknowledgement before sending the next packet. That's basically it has to we have
Hmm.
to stop and wait for an acknowledgement before sending the next packet.
Absolutely correct. To the point answer. So stop and wait is basically we are sending the packet and waiting for the acknowledgement, and then we are sending the another packet. That is basically stop and wait. Now, obviously, there is so much of delay that first we are sending a packet, waiting for the acknowledgement of the same packet, then we are sending the next packet. So we came with sliding window protocols, which include go back N and SR protocol. As you told that go back N is like there is a window which is basically sliding. We like have the questions as well. So whosoever is not able to understand, they'll get the full clarity of this with the questions we'll do. So go back in and MCQs also we have solved for the stop and wait. And go back in is like whole if suppose something is lost, the packet is lost. So whole window is basically retransmitted. Whereas selective repeat, the name selective itself says that only the packet lost is retransmitted. The whole window is not retransmitted. That is the difference between go back in and selective repeat. Now let's see the numericals. I think now the numerical which I'm going to write, it was okay. I'll tell you afterwards. First, let's see. Station A needs to send message consisting of 9 packets to station using sliding window. Window size is equal to 3 and go back and error control strategy. All packets are ready.
Is someone speaking? Is someone speaking?
Hello?
Yes, ma'am.
Hello?
Yes, ma'am, you're audible.
O- Okay.
Yes,
Am I audible now?
yes, ma'am.
Yes, ma'am. Okay, maybe I'm disconnected from the iPad. Wait a second. Sorry for the delay. Am I audible? Screen is visible. Am I audible? Everything is fine now?
Yes, ma'am.
Okay. Okay, can someone read the question and explain it first? Then we'll go to the solution. Yes, yes, come on.
Ma'am, it is talking about a station A which need to send messages
Hmm.
consisting of 9 packets to the station B using sliding window protocol, where the
Hmm.
window size is 3,
Hmm.
and it will use go back and error control strategy.
Hmm.
All the packets are ready for sending,
Hmm.
but if every fifth packet that A transmits gets lost, then what is the number of packets that A will transmit to B for sending the total message?
Hmm. Should I solve it for you, or I should wait for you and you'll solve the next question? Okay, okay. I'll do one thing. I'll solve this question and give you another question so that you can solve.
Okay, ma'am.
Okay. Or if you want to solve yourself, I'll give five, like 2-3 minutes so that one of you can share the screen and show me. Or let's do for the next question.
Yes, ma'am.
Okay. So station A needs to send the message consisting of 9 packets. Now I'm having the 9 packets and window size is 3. This is go back N strategy, first of all. And here what is written, every fifth packet that A transmits, it is getting lost. What is the number of packets, the total number of packets which A will transmit? So I have a sender, I have a receiver. A is transmitting 1, 2, 3. As my window size is 3, so that is I have written here 1. A is transmitting this to B. Now, B is basically getting these messages and giving the acknowledgement of 1. Now, when the acknowledgement is given, now the window is up 2, 3, 4. Fourth is First of all, I want to ask what I have done till now. So I don't want any kind of confusion. What I have done in this step. Can any one of you explain? Yes.
After sending the 3 packets, which is the limit of the window size,
Hmm.
will be sending acknowledgement
Hmm.
for the packet A,
Hmm.
and then the window is shifted to
Hmm.
uh,
Hmm. Hmm.
the next slide, that is
Hmm.
2, 3, 4, and B is also sliding the window to 1, 2, 3.
Hmm. Absolutely correct. Now, as I have got the acknowledgement of first packet, so the window is shifted. Now it's like 2, 3, 4. So now I have basically now 2, 3, 4. Now again I'll get the acknowledgement of the second packet. Now the window is again shifted. The window is shifted to 3, 4, and 5. Now I got the acknowledgement for the third packet. Now the window is shifted for 4, 5, and 6. Now I got the acknowledgement for the fourth packet. The window is shifted 5, 6, 7. But now, as the question says, if every fifth packet that A transmits get lost, I'll not means the fifth packet 1, 2, 3, 4, 5. The fifth packet is lost now. I'll not get the acknowledgement for the fifth packet. It is lost. The acknowledgement when it is arriving, it is lost basically. Right here. Now what to do? Can anyone tell me, like, it's go back and we have discussed now only in go back and what is the next step here? The fifth packet is lost. Everything was working fine earlier. The window size was 3.
Ma'am, it will retransmit back all the packets once again, which were prior to 5. I mean, sending the fifth packet
Okay,
because it
now
has not got the acknowledgement.
it will send which packet again?
Ma'am, 1, 2, 3, 4, 5.
What about others? What about others think, like, will it send 1, 2, 3, 4, 5 as he's saying?
It
As
should send only the ones in window, right?
yes, yes. So which are the ones in windows?
So
Window, I
3,
mean
4, 5.
3, 4, 5. What about other?
Yes, the packets in the window 3, 4, and 5.
Actually, the packets are 5, 6, 7 in the window. The window was 1, 2, 3. I got the acknowledgement of 1. The window is now 2, 3, 4. I got the acknowledgement of 2. Then the window is 3, 4, 5. I got the acknowledgement of 3. Then the window is 4, 5, 6. I got the acknowledgement of 4. Then the window is 5, 6, 7. These are transmitted. This acknowledgement is lost. Now again 5, 6, 7 are transmitted. Any doubt? The window is not 3, 4, 5. The window is 5, 6, 7, as you can see here. If you want, I'll explain again. Any doubt? I don't want to move forward because it's an important concept.
Please explain again now.
Okay. I'll explain it again. So I have a window 1, 2, 3. The window size is 3. So that is why 3 packets are there. Now, when I'll get the acknowledgement of the first packet, I'll slide my window ahead. So now I got the acknowledgement of the first packet from the receiver. That's why I slided my window. Now it's like 2, 3, 4. Then I got the acknowledgement of the second packet, and then I basically slided my window. Now it's 3, 4, 5. Then I got the acknowledgement of the third packet. That's why I slided my window 5, 6, 4, 5, 6. Then I got the acknowledgement of the fourth packet. Then I slided my window 5, 6, 7. Till now, everything clear. Now, what is the window? 5, 6, 7. 5, 6, 7 is like transmitted. Or is there any doubt? I'll again repeat. 1, 2, 3, 4, 1, 2, 3 is transmitted. Okay, it was transmitted. Then the acknowledgement of 1 was sent. Then 2, 3, 4 was transmitted. The acknowledgement of 2 was sent. Then 3, 4, 5 was transmitted. The acknowledgement of 3 was sent. Then again we slided 4, 5, 6 was transmitted. Then acknowledgement of 4 was sent. Then 5, 6, 7. Till now, any doubt?
No, ma'am.
So now 1, 2, 3, 4, I got the acknowledgement, but fifth packet was lost while going. So I didn't got the acknowledgement, or acknowledgement was okay. Here it should be like fifth packet was lost while going. So I didn't got the acknowledgement. So when I didn't receive the fifth packet acknowledgement, I have to retransmit again the fifth, sixth, seventh. Is it
Yes,
clear?
ma'am. Got it, ma'am.
What about others? Got it. I'll delete this all.
So that means, ma'am, I mean, go back and we have to retransmit whatever is present in the sliding window, not what we have actually received acknowledgement for in the previous slides. Okay, that was a confusion I was having. Okay,
Current
now it's clear.
window. Yes, current window. So now 5, 6, 7. Now again I'll transmit 5, 6, 7. I got the acknowledgement for fifth. When I got the acknowledgement of fifth, now my window is basically 6, 7, 8. Now, this was the fifth one. Now, I got the acknowledgement for sixth. My window is 7, 8, 9. What was our problem that what was the question? If every fifth packet that A transmit get lost. First packet was lost was fifth one. Now the other packet will be 1, 2, 3, 4, 5, which means seventh packet will be lost again. So which means I got this, I will not get the seventh acknowledgement because that was lost. So again, I'm not getting the seventh acknowledgement because it was lost earlier. So again, 7, 8, 9 will be retransmitted. Then one more thing, question is, A needs to send the message consists of 9 packets. I'm only having the 9 packets. So now it will be 8 and 9. Wait a second. 7, 8, 9. I got the acknowledgement for 7th. Now 8 and 9 will be transmitted because only 9 packets are there. Now again, 5th packet. Let's count 1, 2, 3, 4, 5, which means 9th packet will be lost. Now, if I I got the acknowledgement for 8th, but 9th, I didn't receive the acknowledgement. Again, I'll transmit the 9th packet. And then I'll receive the acknowledgement. Let's see again. What happened? Let's see again. So that if there are any doubts, that will be cleared because it's an important concept. I transmitted 1, 2, 3. Window size was 3. I got the acknowledgement 1. Then I shifted my window 1, 2, 2, 3, 4. Then again, I got the acknowledgement for 2. The window was slided. Now it's 3, 4, 5. I got the acknowledgement for 4. Sorry, 3. The window was slided 4, 5, 6. Then I got the acknowledgement for 4. The window was slided 5, 6, 7. But as we know, every 5th packet will be lost. So when I was transmitting, 5th was not received. So I didn't got the acknowledgement for 5th. So that is why I have to retransmit 5th, 6th, 7th. So then 5th, 6th, 7th were retransmitted. Then I got the acknowledgement for 5th. Then 6th, 7th, 8th. And then again 5 packets, 1, 2, 3, 4. 5th packet again was 7th because I have transmitted it. Why it's 7th and why it's not 10th? As we think, like as we'll see the question, it's like if every 5th packet will be lost, why it's 7th and not 10th? Can anyone explain me?
Ma'am, because we are retransmitting 5, 6, 7 two
So
times. Yeah.
yes, yes,
So
yes.
that's why it is taking up the count.
Yes, yes, yes. So here again, the 7th was like lost. So 7, 8, 9 was again retransmitted, and then again 9th was the packet, and then 9th was retransmitted. And now what was the question? What is the number of packets that A is transmitting? A has transmitted transmit to for sending to the B basically. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait a second. 8, 9, 10, 11, 12, 13, 14, 15, 16. So total answer is 16 packets. This was the question asked in GATE. So these type of questions may be asked if the difficulty level is high. Though it's not that tough. Now tell me any doubt. If there is any doubt, I'll explain you. Ask me again and again, I'll explain you. But I want that this concept should be clear because it's an important concept. Clear?
Yes, ma'am.
Yes.
Now I'll give you a question. I don't want to rush so that I should cover up the things.
Yes, ma'am.
Okay. Let's see another question. Let me find out. A wants to send 10 frames to host B. The host agreed to go with go back 5, 4. How many number of frames are transmitted by host A if every 6th frame that is transmitted by host A is lost? Now please can I think so the concept is clear. Can you guys solve it? A wants to send 10 frames. As earlier were 9 frames, now it's 10 frames. Only the values are changed. It's just because I want to be sure that you guys have understood. The host agreed to go with go back 4. Now the window size is 4 instead of 3. How many number of frames are transmitted by host A if every 6th frame is that is transmitted by host A is lost? So similar question only. So if any one of you solves, please write in the chat what is the answer. Yes, come on. I'm waiting now. Yes, can anyone tell me you guys are solving it or I should solve? Can anyone write in the chat so that solving it or I should solve? Okay, solving. Yes. Should we solve together or I should wait for you? Yes, can someone write in the chat? 1 minute. Okay, okay. Yes, yes, yes. I'm waiting. It's fine. I want that your concept should be clear. Okay. Aman is saying answer is 16. Let's see. What about others? Aman, can you like click the photo and share the screen if it's possible? Is it possible? Okay. 5, 6, 7, 8, and Windows 7, 8, 9, 10 retired.
Not possible. I'm writing on my notepad.
Okay. 7, 8, 9, 10. Are you sure? I think there is a check again. Okay, let's start and then we'll see. I've also done, but I'm not sure. I'll also solve it with you guys only. Could be wrong. I have also done. Maybe I'm also wrong. Let's see. So we have a sender and we have receiver. Anyone else? 14. Okay, someone is saying 14. Someone is saying 16. Let's see. So now it's like, now can you tell me like first step, what will be the first step? Window size is 4. Let's solve together. So yes. I write like this only rather
So
than
the window size is based on the go back and size, correct?
Go back n means 4. Go back 4 means 4 is the window size. I got the acknowledgement one. I'll write like this. Maybe it's more easier to understand. Window got slided 2, 3, 4, 5. I got the acknowledgement 2. I slided the window again 3, 4, 5, 6. Or rather, that was the better option because I have to count the packets as well. 1, 2, 3, 4. This is the way we have done it. I got the acknowledgement for 1. So I transmitted 2, 3, 4, 5. I got the acknowledgement for 2. So I transmitted 3, 4, 5, 6. I got the acknowledgement for 3. So I transmitted 4, 5, 6, 7. I got the acknowledgement for 4. So I transmitted 6, 7, 8, 9. Now which packet
Should be 5, 6, 7, 8. Oh, sorry.
Is it fine? Oh, sorry. Yes. You are correct. It should be 5, 6, 7, 8. Yes, you are correct. So now I got the packet. I got the acknowledgement for 5.
Now, according to the question, fifth is.
Is it
Sorry. Oh, sixth stream. Sorry.
6th? So I got the acknowledgement for 5th. I transmitted 6, 7, 8, 9. Then this 6th packet
6 is
was.
lost.
Aman, now is it clear?
Ma'am, one question. So, since we are using sliding window, why are we transmitting based on acknowledgement? So we should transmit a whole window in one go, right?
Mm-hmm. So we are transmitting in one go only. 1, 2, 3, 4. This is being transmit. But we don't know that fourth packet was lost until or unless we'll not get its acknowledgement. Like in one go only, 1, 2, 3, 4 was there. Now the other window will not be 5, 6, 7, 8. The window is like sliding here. 2, 3, 4, 5. Then there is a sliding window. And when we'll get to know that the packet was lost while sending, when we'll not receive its acknowledgement. And when we'll not receive its acknowledgement, then we'll retransmit the whole window, whatever the window is at that time.
So in window 5, 6, 7, 8, we send 5. We actually send all 4 packets, but we get acknowledgement of 5, but not of 6.
We'll get only one, like the window is sent, but the acknowledgement is like one at a time. Like I'm getting first acknowledgement, then only I'm sliding the window ahead. When I'm getting this 2 acknowledgement, then I'm sliding the window ahead.
Oh, okay.
Yes. Like suppose 1, 2, 3, 4 was there. I got the acknowledgement of 1. I slided the window like this. 2, 3, 4, 5. I got the acknowledgement for 2. I slided the window 3, 4, 5, 6. And sent. Then I got the acknowledgement. Then the window was again slided 4, 5, 6, 7. And when I'll not receive the acknowledgement of 6, then only I'll come to know that, okay, that was lost while sending. Do I make sense?
Yes, ma'am.
This?
So when we are in Windows 6, 7, 8, 9, we will first transmit all 6, 7, 8, 9, but when we will check acknowledgement, we will see we have not got 6.
We have not got 6, yes. And then if we have not got 6, because this acknowledgement, that is why we can't shift to 7, 8, 9, 10, because we haven't received the acknowledgement of 6. That's why we can't slide our window ahead. That's why we have to retransmit 6, 7, 8, 9 again.
That's why it is very tedious.
Got
it, ma'am. Yes, ma'am. Totally understood now.
Yes. What about others? Okay. Should I proceed?
Yes, ma'am.
Yes, yes, ma'am.
Okay. So now again, I'll basically transmit, as I haven't received the acknowledgement for 6, I'll again transmit 6, 7, 8, 9 again. Now I received the acknowledgement for 6. The window is slided and now it's like 7, 8, 9, 10. I have
So
10.
quick question here, ma'am. Quick question. So what is the guarantee that when we retransmit 6, 7, 8, 9, that we get the acknowledgement for 6 now?
Okay. If I'll not get again, I'll retransmit. But here the question is simple.
Oh,
Like
okay.
the question is like if one time it's getting lost. It's not
Okay.
written twice, or if every 6th frame is getting lost. So there may be a chance that again it is getting lost. So multiple retransmissions will be there. Okay. So 6, 7, 8, 9 again. And then I got the acknowledgement, and then I have shifted to 7, 8, 9, 10. And then as I'm having only 10 frames, I'll say, wait a second, 7, 8, 9, 10. 6th was received. And one more thing, I'll say that 6th frame was lost here. Now again, I'll count 1, 2, 3, 4, 5, 6th. Can you tell me again which will be lost now? Like 6th was 8, absolutely correct. Now 8th will be lost. Then I received for 7th, and now the window is 8, 9, 10. But now again, I'll say this 8 was lost. I didn't receive the acknowledgement. That's why I got to know that this packet was lost here. So again, I'll retransmit 8, 9, 10. And then 1, 2, 3, 4, 5 will not be lost because now there's no sixth packet. Is it clear?
The last section I missed it, ma'am. Could you repeat to that? That eighth. How did you count? Which 6, 7, 8?
I'll tell. First, like I'll start from the starting again, and then if someone is having doubt, they can ask me because it's an important concept. So now it's like I sent the window size. Window size was 4, and go back n. N represents the window size 1, 2, 3, 4, and the four packets were sent. When I received the acknowledgement for 1, I slided my window, and now the window is 2, 3, 4, 5. Now I received the packet for the 2, and then acknowledgement for 2. Then I slided the window again 2, 3, 4, 5, 6. Sorry, 3, 4, 5, 6. Then I received the acknowledgement for 3. I slided the window 4, 5, 6, 7. Then I received the acknowledgement for 4th. I slided the window 5, 6, 7, 8. Then I didn't receive the I'll say the acknowledgement for 6, which means the 6th was lost. That's why I didn't receive the acknowledgement for 6th. So, and we know that every 6th packet will lost. So 1, 2, 3, 4, 5, 6. 6th packet will be lost. So I retransmitted 6th, 7th, 8th, 9th again. Now, if I'll count, I have to count from here after 6th, because the question says if every 6th frame that is transmitted by the host gets lost. We have transmitted 6, 7, 8, 9. So we have to count after 6. This was lost 1, 2, 1, 2, 3, 4, 5, 6th, which means 8th will again be lost. It's not like I'll not count these packet. I have to count from this because we have transmitted. So 1, 2, 3, 4, 5, 6. So 8th. You got it? Why we are taking 8th packet getting lost?
Oh yes, ma'am. So only after the 6th packet. Okay.
Yes, yes. It's not like 6 plus 6, 12th, or 12th will be lost. Or obviously 12 doesn't exist. It will be counted after because these were transmitted. Though 6th was lost, but these were also transmitted. So we have to count from this onwards. So again, 6, 7, 8, 9 were transmitted, and the 8th was again lost. So I got the acknowledgement for 6th. So the window was slided 7, 8, 9, 10. I got the acknowledgement for 7th. The window was slided 8, 9, 10. But 8th was not received. The acknowledgement was not received because the packet was lost. So again, 8, 9, 10 were retransmitted. But when I'll count 1, 2, 3, 4, 5, 6 doesn't exist. So 7, 8, 9, 10. And let's see how many frames. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 frames. I think this was also GATE previous year question, or I think NET previous year question. I don't remember. Any doubts? Please ask me. Should we proceed forward? Yes, come on.
Proceed, ma'am.
Now I'll have a simple selective repeat question. That's very simple. And then we'll proceed. In SA protocol, suppose frames through 0 to 4 are transmitted. Now imagine 0. Wait a second. Okay, this was not the full question. Wait a second. 1 minute, 1 minute. I think screen is again. Zero times out. 2 times out. 5, a new frame is transmitted. 1 times out. 2 times out. And 6, another new frame is transmitted. At this, what will be the outstanding packets in the window? At this point, like I haven't seen the assignment problem. Were there any questions like this also in the assignment problem, or they were like simple, not numerical based, conceptual?
Yeah, ma'am, they were simple, but numericals were there, maybe one or two, but they were simple.
Okay. But they, it might be asked in the like exam and more than exam. Obviously, if you are doing this, go back in an SR. These protocols, you should have the clear understanding.
Yes, ma'am.
So in SR protocol, suppose frames through 0 to 4 are transmitted. Now imagine 0 times out, 5, a new frame is transmitted. 2 times out, a 6 and 6, another new frame is transmitted. Okay, this is simple one only. Maybe I haven't checked. It's like I have 0, 1, 2, 3, 4. 0 times out. Okay, first of all, I'll ask you guys, can you solve? Or let's see it, let's take it as a homework problem. It's your duty to remind me in the next time. I always forget the questions.
From what is written, imagine 0 times out after that.
5, 5, 5. A new frame is transmitted.
Oh, okay. 5 is a new frame.
Just take it as a homework problem. Think about it. I'll give you another question now. Just screenshot it, take a photo of it. It's very simple, very simple. No window size is also given here. I'll give you another question of SR protocol only because it's simple only. So, and please remind me the next class so that, like click the photograph and share with me. Like here only, share the screen and share the photograph with me. Okay. Now, can you solve this second go back and question with the SR protocol? Now, it's also very simple. SR is actually very simple. Have you all taken the photograph of that question?
Yes, ma'am.
Okay. Now, can you solve this?
Yes, ma'am.
It's actually very simple. First of all, can you tell me what is the difference between go back N and SR? Now only in the starting of the class we have done. Yes, come on.
Go back and only in go back and the whole window is retransmitted. Whereas in selective repeat, only the lost packets are retransmitted.
Yes, yes. So SR, selective repeat, only the lost packet is retransmitted. Yes, Narendra, go back and entire window retransmission, and SR, the selective packet will be. Now, can you tell me the answer? It's very simple. No, now whole window is not transmitted, only the selective packet is retransmitted. Should I solve or you guys are solving it? I don't think so. It will take such a long time. Yeah, go back and do take long time, but should I solve? Come on. Or can anyone help me in solving it? It's fine. Because you haven't solved the numericals of SR before. So that's why. Am I audible in first place?
Yes, ma'am.
Okay. Should I solve it or you guys are solving? Or there is a doubt? Come on. Let's give a
No,
try.
okay.
Yes?
Solving now.
Okay. Okay. I'll start. I don't think so. It will take such a long time. It's fine. Maybe you're solving it for the first time. So maybe you might have some confusion. Can someone help me? Yes, come on.
Yes, ma'am.
Now what to do? Like, what is the question? I'll do here only. A wants to send 10 frames to host B. The host agreed to go with SR protocol with window size 4. So if it's SR 1, 2, 3, 4, this is transmitted. 1, 2, 3, 4, then 2, 3, 4, 5, then 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. And here, basically, sixth packet was lost. And if sixth was lost, again, the sixth was again sent. And I have total 10 or 9, 10. and then the 10th packet was sent. That's it. So basically 11 packets are sent.
Yes, ma'am.
The 10 frames which were original and one which was retransmitted. Because it's selective repeat, so that's why whole window was not retransmitted, only the 6th packet was retransmitted. Any confusion?
No, ma'am.
What about others? Should I proceed? Okay. I think so everyone has understood. So let's go to the next part. Which is, so this sliding window protocol, stop and wait protocol, are they clear? I hope so. These go back NSR. I have made it clear. Again, if you'll have any doubt, mail me. I'll make sure that I'll reply as soon as possible. Mail me or ask me in the next class. We'll discuss. Again, we'll discuss more MCQs, the questions, or I'll send you the questions. Clear. Okay. Now coming to bandwidth delay product. Let's increase our speed, because already we are delaying a lot. Like, it's a lot of delay. Okay. So can someone tell me what about bandwidth delay product? What is bandwidth delay product in detail? Yes, come on.
It is a parameter used to determine window size. Basically, it is bandwidth into transit delay, the end-to-end delay.
So basically, it is an important factor, I'll say, to determine which type of protocol also we have to use, or in simple words, I can say that amount of data that can be transmitted in given time, how much amount of data which can be transmitted in a given time, that is bandwidth delay product. Or I can say how many number of bits that can fill the link, that is bandwidth delay product. Or capacity of link, that is bandwidth delay product. So I have a link. This cross section is my bandwidth, and this length I'm taking it as a delay. So bandwidth delay product, I can say it as bandwidth into delay. So suppose if I have bandwidth is equal to 1 bits per second, which means 1 bit can be transferred in 1 second. That is what it means. And delay is suppose 1 second. Oh, sorry. Delay is suppose 5 seconds. What is BDP?
5 bits.
5 bits. So 1 bit per second into 5 seconds, that is 5 bits. So how it was like? Let's see visually. After 1 second, as we have seen, 1 bit can be transferred in 1 second. After 1 second, wait a second. Let's see visually. First bit was transmitted. Then after 2 seconds, 2 bits were transmitted. 3 seconds, 3 bits were transmitted, and so on. 4 seconds, and then 5 seconds. I'll say 5 bits were basically transmitted. And as we have done, what is bandwidth delay product? How much of data, amount of data that can be transmitted in a given time. So how much of data is transmitted within the 5 seconds? That is 5 bits actually. So this is how this happens. And suppose there is a question, quick numerical question. Consider that link capacity of channel is 512 kbps, kilobits per second, and round trip. Before answering a question, let's have a quick discussion about what is round trip time. Can someone tell me what is round trip time? What is round trip time? Yes, come on. Before solving question, yes.
Is the time taken for the signal, I mean the connection to establish between the sender and the receiver, and the acknowledgement in back to the receiver.
Basically two-way time, when we are transmitting and when we are getting the acknowledgement. This whole time is basically the round trip time. Basically, this 2 into the latency, or a two-way going, is basically sending as well as receiving the acknowledgement. Yes? Any doubt? Okay.
No.
Okay. So that is a round trip time. Now, can you tell me the link capacity in bytes? Or in kilobytes or in bytes? In kilobytes, basically. Take care of the units. If you are unable to tell me how we'll solve it. We'll solve together. Not kilobits, kilobytes.
32 kilobytes.
Okay, how you have solved, Aman? Let's solve together. Yes.
So RTT is 1000 millisecond. So link delay is 500 millisecond. That is 0.5 second. And bandwidth is 512 kilobits per second. So that means BDP is 256 bits per second, kilobits per second. Bandwidth is 32 kilobytes per second.
I didn't get it. 1 minute.
Not per second, 32 kilobytes.
Okay. Please mute yourself if you are like Narendra. Please mute yourself. Okay, I've muted it. Okay. You're not doing simply 512 into 1000.
RDT is twice the delay time, right?
So you are here taking the okay, if the link delay it's itself the round trip transmission time. It's not the single transmission time.
Yes, so 1000 by 2.
Okay, if it's single transmission time, then
we will take
link delay is equal to the round trip transmission time. Then I'll take 1000 only. Then what's
then divide by 8. So that will give us bytes, total bytes.
Yes. Okay. That is 512,000 divided by 8. Okay, that is around
64,000.
64,000 bytes. And then in kilobytes?
64 bytes.
Or if I say 1024, if I don't take it as that, then I can say 62.4 kilobytes. Am I correct? Is it clear to everyone? Should we proceed? Let's proceed. So there was a question in the presentation in the class as well. Like suppose the bandwidth is 50 kbps, one-way transit delays 250 millisecond. What is BDP in kilobit? Tell me fast. What is BDP? Yes, come on.
12.5 kilobits.
So basically 50 into 10 raised to power 3 multiplied by 250 into 10 raised to power minus 3. So basically it's like 12500 bits and 12.5 kilobits. Any confusion? Now the next thing was like assume 1000-bit segment. If anyone is having confusion here, let's see. So BDP is how many segments? Yes. Basically, can I say that here one segment is 1000 bits? So 12.5k bit is how many? 12.5k over 1000, which is equal to 12.5 segment only. Am I correct by saying this?
Yes, ma'am.
So basically I have 12.5 segments. And now if we have round trip time, so basically we'll multiply by 2. That's 12.5 into 2, that is 25 segments. Any doubt?
+1.
+1. I'll come to that. Why +1? You mentioned that it's like you're absolutely correct by mentioning that, okay, it's 12.5 into 2, that is 25. Now you mentioned +1. Why +1? You only mentioned.
Acknowledgement is sent only if the first segment is received.
Can you make it easier? Like, what do you mean by acknowledgement is sent only first segment is received? Can you say easy words? Yes, yes.
I think the idea is that for the first packet or segment that we send, for establishing the connection. So probably that is being referred.
Yes. Okay. Like I'll tell. What about others? Are you getting it? I'll come to this +1. First of all, I'll ask others. Are you getting it? Or I have to explain it again? Only someone has. Nilanjan has said no. Okay. Nilanjan, can you ask me what is the doubt? Or I should repeat again everything? It's fine for me.
Repeat the last segment one. I actually didn't hear that properly.
Okay. +1 or the whole segment part?
The whole.
Okay. Sure. So let's see. Like what we are doing is we are saying that assume we have 1000-bit segments, and which means one bit, like one segment is 1000 bits here. So how many segments are there in the 12.5 kilobits? So it's simple. If one segment is 1000 bits, then 12.5 bits is how many segments? 12.5 divided by 1000. Simple mathematics. Multiplying by this and dividing by this. Simple mathematics part. So we have here 12.5 segments. And now we are taking it as we are having a so the question is how many maximum number of segments are there. So in round trip, in both the pipes, one is sending pipe and one is receiving one, because here the acknowledgement part is there and here we are sending it, like sending the data here. So which means the round trip time and the segment, like we'll have total 25 segments. 1000. Here we only calculated how many segments are there, And in 2 pipes, there was 12.5 segments. In 2 of them, it is 25 segments. Then they have written that it should be 25 plus 1. That's what I was asking, why plus 1 is there. Maximum number of segments. Why plus 1 is there? Because when we are sending the first one, when we are sending the first data, this acknowledgement pipe is basically empty. No acknowledgement is there. So here it was there, like 12.5 are here, 12.5 are here segments. That is why we got 25. But when we are sending the first one, this pipe is basically empty. This acknowledgement pipe is empty. So that is why we are saying plus 1, because acknowledgement will be like last acknowledgement we'll get afterwards, because the first time when we are sending, this acknowledgement one is empty. That's why 25 plus 1. Maximum number of segments within this duration. How many number of segments can be outstanding within this duration? That is basically 26 segments. Is it clear? Or
Yes,
again,
ma'am.
what about others? Yes. Yes, yes. Yes, okay. So, are you sure, everyone? Should I proceed? I think I was too fast. Is it clear? So maximum link utilization, I can say it's like W is equal to 2 BD, bandwidth delay, plus 1. Because when we are sending the first time, and then basically the acknowledgement one is empty. That's why the acknowledgement a pipe is basically empty. That's why we are doing the plus 1 here. Okay. So now this thing was also explained in the class only, like BDP. Bandwidth, suppose, is 1 Mbps. Delay is 1 millisecond. What is BDP? Yes. Come on. Just multiplication only. Come on. Absolutely correct, Narendra, Aman, Savita. It's basically 1 kbps. KB basically, not kbps. It's like 10 raised to power 6 into 10 raised to power minus 3. That is equal to 10 raised to power 3, which is equal to 1 kb. And suppose the segment size is 1 kilobyte. Now, which means that we cannot hold the BDP. What is BDP? As we have like done here, the amount of data that can be transmitted in the given time. And the segment size is 1 kilobyte, whereas the amount of data which can be transmitted is 1 kilobit, which means that the segment size is much larger than the amount of data which can be transmitted. The link cannot hold entire segment. So multiple segments are sent. So which one is here better? Which protocol is better? Go back and SR or stop and wait? Now, can you explain me like what I am referring to, so that whosoever haven't understood, please can you explain me, and then can you tell me which ARQ protocol is the best one, or which protocols flow control protocol is the best one here. Okay, Dr. Savita, she's saying SR. What about others? Stop and wait, Aman. You are saying, please can any one of you unmute yourself and first explain this concept, then tell me the protocol. What is the whole concept I'm referring to? What is the question? Yes, come on. Yes. Savita, Aman, Nilanjan, Joseph, please. Any one of you or any other person? I want everyone should be interactive, not only 3-4 students, these 3-4 only. Yes, Narendra. First, explain me this question. Come on.
Not sure, ma'am.
Only start. Okay, let's try. Explain the question. Let's try. What I'm trying to say is, maybe if you guys have not understood, what I'm trying to say is bandwidth is 1 Mbps, delay is 1 millisecond. So what will be the BDP? So I calculated BDP. BDP was the BDP formula is bandwidth into delay, which is basically 1 kilobit. And the segment size is given. It is given that is 1 kilobyte. Now, can you tell me, any one of you, what is BDP and what is segment size? What do I mean by BDP and what do I mean by segment size? I calculated the BDP. Is this clear, first of all, the calculation of BDP? Is this clear?
Yeah,
BDP.
yes, ma'am.
Okay. Now, what is BDP? What is segment size? Okay, Aman. The idea is to check how many segments can fit in the pipe. If it is less than 1, then no need of sliding window, else otherwise. Absolutely correct. Okay, I'll tell others also what he has written. He's on point, written very correctly. Now, BDP refers to how much amount of data that can be transmitted. So, what they are saying is 1 kilobit can be transmitted. Only 1 kilobit. Whereas segment, how much data we are having? 1 kilobyte. Which means the data or the segments which has to be transferred is much more than the capacity of the pipe. Can I say this? Is it clear what I'm trying to say? The link which is holding, that is only 1 kilobit, whereas data or the segment is 1 kilobyte. Can I say the data which has to be transmitted is much more than the capacity of the link? Am I correct by saying this? Yes. Come on.
Yes, ma'am.
Yes.
So if the data which has, the data which I have to transmit or the segment size which I have to transmit is much more than the capacity of the link, which means I have to transmit in like multiple goes. It will not be transmitted in one go. So multiple segments, like first I'll transmit first segment of the size 1 kilo, 1 kilobit, of 1 kilobit, then another 1 kilobit until it's 1 kilobyte. I'll send. So now the question is, this was the question, that now which protocol is best used for this? If I talk about go back and SR protocol and stop and wait protocol, in stop and wait, what I have to do is like I have to transmit one and then wait for the acknowledgement. Whereas go back and like I can transmit multiple frames at a time. But here I can't transmit multiple frames at a time. There is no use of that because I can't transmit one frame also at one time. Are you getting my point? One frame itself is like so big that it is not able to transmit in one go. So I have to transmit like 8 times the one frame only. Like what we were doing is, in go back N or like in SR protocol, we were making a window 1, 2, 3, 4, or suppose two window of two size only, like two only. Window size is suppose two only. That also I can't, because the first frame itself, first segment itself, it is being retransmitted in multiple cores. I'll transmit first, then second. These are all one frame, consisting of one frame, because my segment size is much larger than the capacity itself. So there is no use of these complicated protocols. Stop and wait is best one. I'll send the stop and wait, and I'll wait for the acknowledgement, because I can't transmit multiple frames or packets parallelly. And as I know, stop and wait is very simple. So though I can use any one of them, but it's the simplest one if I go with the simplicity. So it's better to use stop and wait, because parallelization, sliding window protocols, anyway I can't do. Clear with this point?
Yes, ma'am.
What about others? Okay. If you are not clear, please write in the chat. I'll explain again. No worries. Okay. So that is why I can't do any parallelization, because only one frame I'm unable to transmit, one packet I'm unable to transmit at one go. So how I can make a window size of 2 itself also? So window size, or it will be one only. So if it will be one only, and one also I can't transmit in one go, so it's better to use the simplest one, which is stop and wait protocol. That was the main idea, because it's less complex. Okay. Now, this was the BDP part. Cleared with the BDP. Should I move to the other concept? Should I move forward? Okay. Let's move. So we have a user space. We have a kernel space. User space is basically the application we are running at. Kernel space is basically the OS part, the heart of the operating system. We say that is basically the kernel. That we run like transport layer, network layer, all they are running the these layers basically run in the operating system. Whereas application, obviously, it will be running on the user part. So how they interact, basically, suppose the application is here and we have the transport layer here. So now the rate, I'll say, at which I'll have here write at. Right. Please, someone explain. Can someone explain what I have written? First read it, and can you explain in detail? Detail means like what I have written and what can we do for this? Yes, come on. Come on. Let's be fast somewhat.
Ma'am, it is talking about the rate of transmission from the application layer to the transport layer, and then further below to the next network layer.
So what can we do? What they're saying is, like, if I'm transmitting, if the application is transmitting to the transport layer, suppose at 10 Mbps, and transport layer is to network layer at 1 or 2 Mbps, then what will happen? Obviously the packet loss will happen if that there is so much of delay, like rate difference there, then what can be the solution?
Minimizing the uh, application layer rate,
Okay. Or what can be the other solution?
or we can use a buffer in between to store the.
So yes, either minimize or we can use the transport layer buffer. What will a buffer do? As you have said that, okay, there'll be a buffer. What is the use of buffer?
It will store all the frames and it will transmit it as per the transport layer's rate of receiving. So it
Bas-
will simply cut down the speed.
So basically, the application layer will send to the transport buffer, and then transport buffer will send uh, further, and then the transmission rate control and everything that will be taken care by the transport layer. And so this buffer is basically for the storage purpose, so that there shouldn't be the packet loss because of the rate difference here. That is basically the main concept of this buffer here. Now, if I talk about the organization here of the buffer pool, how this buffer segment size organization, so we can have the fixed size segments as well as the varied size as well, variable segment size as well. So in variable sizes, one way is like we are using like a linked list, and the other way is like circular list, which means like I'm having a segment in the buffer. Suppose this is 1 KB, this is suppose 2 KB, this is suppose 5 KB, this is unused. So which means that whichever is lesser than a segment lesser than the 1 KB, they'll be here, 2 KB, they'll be here. So this is basically the buffer pool, which is having the good I'll say better memory utilization, and whenever the connections are so much heavy, so we are having a single large size buffer, and this is the way they are basically organized. Now as you also talked about the like we can also minimize the difference of the rates also. Let's see that concept also. So this was only the buffer thing, like we are basically having a buffer, so that the buffer should store the packets before it is being sent further, so that there shouldn't be the packet drop. Now the other thing is, I have the application layer, I have the transport buffer here as we have done, and I have the network layer here. At the sending side also and at the receiving side also, basically we are having the the transport buffer here. Now what does if the transport buffer get full? What will happen? As we have done that, okay, there is a solution, that is we can have a buffer which can store, and so that
Packet drop happens because no further communication can happen.
so now what is the solution?
So the sender will have to lower its sending rate.
As the other person, I think Nilanjan has said now only, and you are also saying so sender should send according to the receiver buffer space, like they should adjust it accordingly, the rate in which they can receive it. That is basically there. What is congestion control? I'm not going through that example which is discussed in class. That's simple only, if you want I can it's the simple only, what how we are requesting, how basically it's the acknowledgement is sent, and how the rate is basically maintained there. Now can you tell me what is congestion control?
Ma'am, to control the flow of the packets so that they don't get accumulated or get lost
Hmm.
while they are taking through the route.
Yes. So basically now we are basically regulating the flow of packet or data when they are transmitting between the flow of data between the sender and receiver, so that the packet shouldn't be lost. That is what. And now there was a diagram also there. Let's discuss that. Bandwidth allocation. And this is the time part. Bandwidth, it is an Mbps. So now I was having flow 1. I'll first draw the diagram and then we'll discuss. Like, wait a second. Can someone explain me this diagram? Bandwidth allocation versus time. Congestion control in network. I am changing the bandwidth allocation over time. This was discussed in class. Come on. Yes, yes.
Ma'am, so it is basically going through a first flow in the connection, and when it is finding that the packet loss is happening, so it is cutting down the flow and going further down with the second flow. And again, when it is finding that it is creating congestion, so it is again cutting down as per that proportion to that flow. And after a while, when it is finding that it can allocate more bandwidth, so it is increasing the flow and going with that flow again in the last one.
Let's correctly explain. Let's see. Now earlier, what this diagram is saying, I was having 1 Mbps of bandwidth, which has to be allocated. I was having only one flow 1. So that is why whole bandwidth was allocated to the flow 1. Now flow 2 came into picture. Now I divided it. Basically, I divided into 2 halves. That is 0.5 I gave to flow 1 and 0.5 I gave to flow 2. This is flow, which means flow 2 is having this 0.5 and flow 1 is also having 0.5. So 0.5 was given to them. Now, sorry, I have to wait a second. Sorry. So this flow 1 is having 0.5 now, as well as the red line flow 2 is also having 0.5 till this point. Till this point, is it clear? Is it clear till this point?
Yes, ma'am.
What about others? Only one person is answering. Yes? Is it clear? Yes?
Could you repeat? I think this kind of is a little confusing. Yeah.
Yes. So what we are now checking is how much bandwidth is allocated over time. Okay. So I was having only one flow. only one flow. So whole 1 Mbps was the total bandwidth that was allocated to one flow only, like this flow only. There was only one path. So whole was basically given to this path. Now there were two paths. Again, one flow came into picture at 1 second. So at 1 second, another flow came, another path I have to give it. So I divided my bandwidth into two parts. 1 Mbps was divided into two parts. So now flow 1 became, this white line is flow 1, became 0.5 Mbps, whereas flow 2 also became 0.5 Mbps. Is it clear? Till this point now, is it clear?
Yes. Yes.
Flow 3 came into picture. Flow 3 don't want that much of bandwidth, suppose. It do want only a small amount of bandwidth, as flow 2 wanted a 0.5 Mbps. So when flow 3 came into picture with the like very small amount of bandwidth, again flow 1 and flow 2 bandwidth was reduced, because flow 3 is also using some amount of bandwidth, and remaining was shared with the flow 1 and flow 2. Now after some time, say 9 seconds, this flow 2 stops. This path is done. When this stopped, again, like this was going on, this flow 3 was going on. Again, the flow 1 basically now is having more bandwidth, though lesser than 1, because very less amount of bandwidth is used by flow 3. And like I'll say, the remaining amount of bandwidth is used by the flow 1. This is like how we are changing the bandwidth, dynamic bandwidth allocation over time. Is it clear?
Yes, thank you.
Yes, ma'am.
Ma'am, so over here we are actually not measuring the one flow, but we're actually measuring all the flows together.
We are having multiple flows. So how bandwidth is located among the multiple flows, they are saying. Just simple thing only. How the bandwidth allocation over time is among the different flows. Like when one flow is, there was a one flow only, whole bandwidth was allocated to that path. But when the multiple flows are coming, the bandwidth of that flow goes on decreasing, so that other flows can also have the bandwidth allocation.
So I mean the last it is flow 1 and flow 3 which are competing.
Yes.
Got it, ma'am.
So they are entering and exiting basically, and we are having this this flow thing. And so now coming into congestion avoidance, how we can avoid the congestion here. I'll write it. Maybe we'll though it was explained in the class before only, maybe you'll not get this concept. We'll go to AIMD and then you'll like get to know about this formula in more detail. Can someone explain, if they know, what do you mean by sending rate is equal to minimum of network rate and receiver rate for congestion avoidance?
So, ma'am, this is like the adjustment of sending rate based on if packet drops happen or something. So,
So
in network rate, we use the AIMD algo, and in receiver rate, it is advertised by receiver how much buffer it has.
absolutely correct. So basically, as Nilanjan and you told me that sending rate should be basically adjusted based on the receiver rate, so that congestion shouldn't be there, packet drop shouldn't be there. So receiver rate is like whatever the receiver is saying, I'm having this much of buffer. Maybe I haven't shown that example. That's simple, like I'm having this much of buffer size, so give me this, send me this much amount of data only, don't send me more amount of data, so that it shouldn't be lost, the packet, so that it shouldn't be lost. Now network rate is, we'll see in the AIMD like part, additive increase, multiplicative decrease. We'll see in that like how, what we are doing is we are increasing the network rate gradually, like slowly, and when it is like reaching the receiver rate, we are basically like that's the maximum capacity, then we are trying to decrease it. So maybe I'll explain this part after explaining the AIMD rather than explaining now only. One more part, like AIMD, one more part. Can someone tell me what is max min fairness? I'll come to this part, don't worry. What is maximum fairness? Yes, come on. Come on, guys. We have to do the numerical as well of AMD. Maybe it
So
will.
it
This
is
part was not clear when I saw the video. So
Okay,
can you
okay.
please explain?
What about others?
so it is the ideal flow. So if so it means that basically you have to increase after this has been achieved to increase bandwidth of one particular route you will or you will have to decrease for some other thing.
Yes, yes, yes. So what they're saying, if you have to maximize, increase the bandwidth of the one flow, it like we have to decrease the bandwidth of the another flow, which means suppose this is or I'll simply say bandwidth increase, like I have to increase for the one flow, then decrease the bandwidth of the other flow. Let's see how it is happening. I'm not here drawing the routers and all. I'll first try have the diagram. Sorry. Maybe I have to draw the routers, then only. One minute. From next time, I'll take the screenshots or the pictures so that it shouldn't be like the time shouldn't be wasted here. Rough diagram only. Just we have to see how the things are happening. Yes, can someone explain me? Come on. Come on, come on. Yes, someone you were explaining. Can you explain me this diagram?
So in this diagram, so basically it means that changing flow of any in between route will have to, if we have to increase one, we will have to decrease something. So some compensation will have to be in. You
Yes.
cannot increase it without any after effect.
So this is the full link, can I say? 2/3 is shared by this and 1/3 is here coming from this route. So that is why this was 2/3, because here it cannot be like full. And if I have to increase this, basically I have to decrease this one. Here it is going. And here also, I'll say not total capacity is utilized. Can I say here total capacity is not utilized?
Yes,
Can you tell me why?
because 1/3 is going up in
One,
the previous.
basically it's 2/3 of the capacity which is utilized among the total, and 1/3 is going up. Here can I say here the total capacity is utilized?
Yes, ma'am.
And suppose I want to increase it. So what to do? I want to increase this 2 by 3rd. Now what can I do?
Increase by how much?
Increase, I can say 2.5 or so. So I have to decrease this.
Yes, ma'am.
Because further they'll like total capacity is 1. Suppose 2 by 3 plus 1 by 3 is equal to 1. So I have to decrease this in order to increase this. That is basically maximum fairness. What does it mean? That in order to increase one, I have to decrease the other one. Got the concept?
Yes, ma'am.
Here the total capacity is used 1 by 3rd, 1 by 3rd, 1 by 3rd. Here again the total capacity is not used basically. So if I want to increase one by increase them by some proportion, I have to decrease this one which was going up by some proportion in order to increase these links. So that is basically maximum when the bandwidth given to one flow cannot be increased without decreasing the bandwidth given to the another flow. That is the maximum. Now coming to AIMD, though I don't think so we can discuss today. It will take time. Okay, just summarized version. Can someone tell me what is AI? Because it will take time. We'll discuss in another class the numericals as well as this. Yes,
Ma'am,
come
so
on.
it means we have to increase the flow in terms of the addition and decrease whenever we have congestion in terms of multiplication.
Yes. So basically, if I have to increase, then I have to increase in the terms of addition, and decrease, I have to decrease in the terms of multiplication. We'll discuss in the next class because I don't think so it's possible in this class. It will take a lot of time. Any doubt till now? Maybe this go back and sliding window protocol, they took a lot of time, but I think the numericals were important. We are way behind. Okay. Additive increase, multiple decrease, multiplicative decrease. You are correct, Aman. Any doubts in this class?
No, ma'am.
What about others? Okay, thank you, class. So, as this topic will take a lot of time, so we'll discuss this AIMD and what is left further in this transport layer, the TCP thing. Before TCP, the next topic is, I think, TCP only, and before TCP, the minimal things like are left only. That will not take much time. AIMD will be taking a lot of time. Otherwise, those are the minimal part only. The summarization of the whole services, then TCP, UDP, and socket part. We'll
Yes, ma'am.
discuss in the next class.
Thank
So,
you, ma'am.
okay, thank you, class. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you. I hope the lecture was fine. Any feedback? Was it fine?
Yes,
Any
ma'am.
doubts? Okay. Thank you so much.